My name is Chris Scott. I'm going to be talking about a technology that I doubt anybody's actually heard of before. So I'm going to start from the beginning and go through it. I work in Northern Ireland. I work for a company called First, which is a consultancy for this technology, KX, and I manage one of the a nearshore operation we have there that I actually use for Morgan Stanley. I'm a developer as well, so I have plenty of experience in this. So just in terms of a quick agenda about what I'm going to talk about, I think I've got about half an hour, is that right? Yeah, cool, right. So I'm afraid I'm going to have to start off with a bit of marketing stuff. I know that obviously being a fun tech meetup, maybe not what everybody wants to hear, but if I don't start with that, you're not going to know what I'm talking about, so I'll do that. So what is KX? A bit of history about it, some of the stats, comparison versus other languages. I'll do a bit of a live demo so you can see some bits and pieces about it. Obviously, it's been in finance for many years. It's been in existence about 25 years now, but outside of finance, no one's ever heard of it before. That's not quite true, because in the past few years, some places have been taken up because they've been looking outside of their industry to find out how other places use it. So I'll talk about a few cases there. A bit more marketing in terms of resources where you can go and find out how to use it, test, develop it, and then we'll take some questions at the end. At any point in time, feel free to stop me and ask questions if you want to do. I'll try and answer things, but there may be some questions I can't answer. Okay, so starting off, so what is KX? Okay, so a bit of a disclaimer before I start. There's a bit of rebranding going on. Traditionally, the KX is the company. The database technology has been called KDB+, and the processing language is called Q. They're rebranding it now, so everything is just referred to as KX in terms of technology and dropping the KDB+. But if I say KDB+ at any point during the talk, I'm talking about KX. I think I've got the branding right, but just so you're aware. So KX, so integrated columnar database and programming system. So if we look at the underlying technology, KX, it's in-memory and on-disk databases. Columnar-based, so different advantages. And instead of having to have one technology for on-disk and one technology for in-memory, it sort of allows you to combine the two together in the same structure, so you can very easily talk between the two languages. It has a client-server architecture, so processes talking to each other. It's built in IPC communication to get everything linked up, so it's really easy to get something up and running and talking between each other. Q then sits. Q is the processing language that you query with, run just general processing with. It's a fully interpreted language, and it's a vector processing language. The vector processing is quite key to the whole thing, especially with the column store. So whenever something's stored in a table, each column is effectively an array. We call them lists, but an array in other languages. And instead of having to loop around if you're processing that, it actually applies the whole list to the function itself. So that allows you to get some really incredible speeds with the data on disk, because it means whenever you're doing queries, especially in finance where you want to be able to query over the whole day, you're only looking at a couple of columns. So if you've got a table that's 50 columns wide, you're probably only actually going to want to do like something like a weighted average between the size of the trade and the price of the trade to be able to work out the weighted average of the price during the day. Which means you only need the 2 columns. If you want to group by like symbol, 3 columns, so you only have to actually read 3 columns there off of the disk rather than the whole table. So it allows you to really get some real benefits out of it that way. Also has an SQL-like syntax for data extraction analysis. So all of this data is searchable and within on memory and on disk to allow you to get access. Sorry, it's not working. So who uses it? So we've got lots of places there. Typically financial institutions. It was developed by a guy called Arthur Whitney, as I'll talk about in a minute, within Morgan Stanley. And it's pick the top investment banks in the world, and they're all using it to run basically all of the data that's coming off the stock exchanges to store it and search it. So an example of just the sort of quantity of that, in the nearshore office that I work in Northern Ireland, one of the teams manages the FX plant, and they take in about 1.3 terabytes of data a day across globally across London, New York, Tokyo, and Hong Kong. So they're keeping 1.3 terabytes in memory per day, storing that down on disk, and then being able to do analysis between all of that data to be able to provide results to the traders. It's also used by the likes of the quants and programs traders to be able to do high frequency program trading, where when something changes and breaches the threshold, they're automatically getting processed. And that obviously, the way that works is they make small margins on lots and lots of trades that happen over milliseconds. So that they need someone that's able to basically keep up with that. And they need to be able to not only be able to process the real-time data as it comes in, but also be able to compare that to the data on disk, because they won't be able to have a historical record of average prices and the things that happened in the past to be able to compare that against. Exchanges now have been taken on. What the exchanges use it for is actually, in a lot of cases, for surveillance. So I'm not sure if ASIC is actually mentioned on there, but the Australia Securities Investment Committee, is effectively the equivalent of the SEC in Australia, they use KDB, or KX, sorry, to monitor all of the trades that are happening during the day to be able to look for fraudulent activity. So, for example, if someone, they won't be able to see people, if certain announcements are made and people are making big trades before that, there might be some sort of insider trading going on or something like that, and they're able to stream all that results. They can then sort of drill down and replay parts of the day. So if they think that there might have been bits of activity happening at a certain time, they want to replay that, they can go and replay that part of the day, slow it down so they can see what happened and what were the sequence of events that happened to get up to that point of view. Moving on then into Pharma. Pharma is quite a recent one. I think it was maybe 3 or 4 years ago. I think it was some guys from Wall Street effectively rocked up to Purdue Pharma in Connecticut and said to them, we're going to redo your entire database for you. And so they use it for their sales data. Previously, they had to get the results that they wanted from their sales data. I don't have the details of the size of the data. It is quite big. But it was there was like a 2-week process that had to go through in terms of going to the reporting team, going to the database team to get the results to then be collated and formatted to give to the business to actually get to make decisions. And now they're able to do that within milliseconds through using KDB+. So using utilities, we'll talk about that in a bit. KX, sorry. So used to calling it KDB+. Utilities, I'll talk about that in a minute. I've got some examples of that. A big one in the utility space is the energy regulator in Ontario. Uses KDB+ to regulate all of the sensor data. They have smart sensors in all of the boiler systems, and obviously it's all time series data coming off, and it's structured so it actually ends up being quite similar to the sort of data we're seeing in stock exchanges to analyse what usages are and all that sort of stuff. So I'll talk about that in a minute. The military, the US military use it for user access control or something like that. I'm not sure, unfortunately, I don't have those sorts of details. So why do you use it? It's performance, lightweight, that's badly written. Performance is the key thing. I mean, it's so fast, and each process is single core, but you can multi-thread over multiple cores. And because of the fact the vector processing element of it, the way that it allows you to just get a really leverage as much of the technology, the underlying system as possible. An example for that is that there was a bank that did analysis to work out a new system they wanted, and they did a comparison between using Q or KX and Java just to see what the difference would be. They worked out to deal with what they needed. They needed about 50 machines running Java, or 2 machines running KDB+ or KX. Sorry, and it's incredibly lightweight. If you can see the bottom point there, tiny footprint of the whole binary for KX is 500 kilobytes. The whole thing sits in system cache, so and downloading it doesn't take anything at a time. Unlike downloading Java, which can take a bit of time. Very flexible, scalable. It's designed to be flexible and scalable to be able to build these systems that can take in this sort of volumes of data. Independent benchmark, I'll talk in a minute. It's this stack research. I don't know if anybody will have heard of them before, but they're an independent council that run benchmarks on different technologies. And KX wins in the time series element of it a lot. Throughput, CEP stands for complex event processing. So throughput, obviously, as we've talked about, 1.3 terabytes a day for FX. So you're dealing with huge amounts of volume coming through on it in real time. CEP, complex event processing, as I say, being able to do things like high frequency trading, data response times, maintenance and infrastructure arbitrage, as I was saying, just the amount of computers you need. It runs on commodity hardware, but the amount that you actually need is reduced. You do need quite big RAM, obviously, for the amounts of in-memory data, but other than that, the actual number of machines you need can be quite reduced, which means that you can reduce the overall infrastructure of your system, which means you have less system overheads. So, a little bit of history. it's all based on APL. So if anybody, do I have any APL developers in here? No? Okay. So 1962, Ken Iverson invented APL. It's an array programming language. This one, once again, this is the idea of being able to, instead of looping around individual elements in an array, you just pass the array into your function and it works. And an incredibly efficient notation, which I have an example of here. Which nobody understands, and you need a special keyboard for it. So, yeah. So anyway, along comes Arthur Whitney in Morgan Stanley, an APL developer, and rewrote it into A+, which was a little bit different again. But then he realised that everybody needed this. Like all the banks needed to be able to do this processing. So he basically rewrote it and came up with K, which he then set up a company with and created KX Systems, which is the company. And K at that point is an in-memory processing language. It didn't have all the database stuff and everything connected to it, but it was the ability to be able to run processing on these with a language that didn't require a keyboard but still very efficient. 1998 then he brought in the database side of it, so being able to keep on disk in-memory stuff. In 2003 we had Q, which is K is still a very difficult language to understand, whereas Q is readable and understandable, and what I develop in, because I would not want to be writing something in K. So the example we had there before in APL, which was lots of weird characters, the K example is not much better. But you can use a normal keyboard for it. Okay, it is a normal keyboard. So one line allows you to solve any Sudoku puzzle you throw out, as long as it's a solvable puzzle, of course. But yeah, with one line of code you can solve any Sudoku puzzle. The example at the top there in Q, you could probably rewrite this again and make it a little bit cleaner and neater to understand. But as you can see, the point is here that there's actual words in there that you can understand, so you can sort of follow along and figure out what to do. Traditionally, one of the reasons why Q isn't very well known is partly because people think it's very difficult to get into, because they see things like this and go, what's the point? It's just really too difficult to understand. As you'll find out, especially if you read the book, it's actually really straightforward. We take graduates in and have them on site doing, working like they've never even programmed before, within a couple of months where they're actually able to do stuff. I mean, it is actually very understandable. There's not that much to it. It's quite lightweight, and so as long as you know as long as you know about computers, it's very quick to be able to jump in and just start using it. So, some statistics. This is where it starts to get interesting. So, 3 million single inserts, updates, joins, and selects per second per core. So, as I say, it's a single-threaded. Like each process is single-threaded, but you can basically leverage slave threads and be able to multi-thread it. So, per core, 3 million, and that's if you're doing one row at a time. If you're doing batches, you can bulk insert 20 million rows or updates, joins, selects per second per core. So you start to realize, this is it's able to do an awful lot. In terms of querying, then 300 million records per second of in-memory table scans. Okay, that's slightly different on disk, because obviously on disk you have to read it off of the actual hard drive. But once again, that allows you to you get an idea of being able to run queries on this as well as insert. Allows you to do an awful lot. So it supports streaming, real-time and historical analysis on the one platform. And that's basically the whole key thing. It's one platform that does all of this, and so fast that nothing else just can compete against it.
How big are the rows in these examples? Because I can imagine...
It doesn't matter, because it's column-based.
Yeah, but it still does matter how many columns in a row there are for inserting, I think. If only it's stopping enough pointers.
Yes, okay, that's fair enough. Well, I've seen tables with 5 rows, I've seen tables with 100 rows, or columns, or, however, I've seen ones with possibly 200. You can have as many columns as you like. I don't know how much it will affect what that statistic was run on specifically, but yeah, I can't answer that one directly. But yeah, so it supports thousands of concurrent time series and billions of rows of data. So we'll see in a second. I'm going to do a bit of a live demo in a bit, and you can see some things with some sample data on the database. So the size of the database is only limited by disk and RAM capacity. Fairly straightforward. Reading, loading figures. So being able to parse sort of KDB into the likes of JSON. There's now the newest version. A JSON parser inbuilt into it in the C binary underneath. So they're able to leverage that to parse it really quickly. And the way the whole structure works, because it uses dictionaries. Like tables are based around dictionaries and I'm not going to go into too many technical details there. But a dictionary in KDB Plus lines up very nicely with the JSON object. So it works very nicely being able to sort of talk between the two. And open APIs to third-party applications. So any other technology we've come across, we've been able to connect to KDB Plus and be able to talk between the two. It's quite straightforward. So then there's the bit at the bottom there about KDB Plus called Independent Benchmarking Record with Stack. So we like to think of Stack as being like the Olympic Games of computer programming, and KX is like the Jamaican sprinting team. So a bit of comparison here. Now, before I go into this, I'm going to say these are results that were run by by the team in the FD labs over in Canada Sunday last year. I don't know how accurate, how the other queries were designed in the other languages, but it gives you an overview of sort of what was happening. We're looking at the nicely tacked data, which is the trading quote data for 5,000 days, 1.1 trillion quotes, 65 billion trades. So it's 100 terabytes of raw text, basically. Running on commodity hardware, so a machine with 16 cores, 56 gigabytes of RAM. State partition and symbol indexed up. Probably won't go. Well, I'll talk about date partition in a bit. You'll see what that's talking about. Queries roll in RAM, so in terms of getting the data off disk into RAM and then running the queries on. So I think we're actually, the results that are in this table are all for the smallest day of trades on, what was that, the 10th of September 2003? I don't know why it's 2003. 35 million quotes and 5 million trades. Okay, so these are standard queries, things like select maximum price, minimum price by symbol, select the weighted average by symbol for price and quote. Query 4 is actually a bi-temporal query, where it allows you to basically, you've got your trade data, and for each trade during the day you want to see what the prevailing quote price was in the quote table, because obviously you want to be able to see what probably happens is that your trade will be somewhere between the buy price and the ask price. So you want to be able to compare the two tables to get the prevailing price. And so you're doing, that's the sort of join you're doing in query 4. So as you can see, KB Plus is so much smaller in a lot of cases. Query 4, most of the other languages just didn't even manage to do it at all, they didn't finish. And even in terms of the overhead, so overhead milliseconds is how much time it sort of takes to load the stuff onto disk to actually be able to run the query. RAM is amount of megabytes that it uses to actually run the query, and on disk is that day's worth of trades, how much it takes up on disk. So you can see that there are cases like, for example, Impala uses less space on disk, but I mean most of the other places it just comes out so much faster than anything else. So, but as I say, it was run by one of our labs in Canada. I don't know, I'm not sure if they're what their knowledge of the other language is like, so I don't want to be saying this is being all and end all, but it still just gives a very good representation of how much quicker. So KX is 10 to 100 times faster than other column stores, so vertical, big 3, so I think it's like a Hadoop. I don't know the other technologies that well, but in terms of row stores, especially like SQL run these sorts of queries where you're trying to go across days effectively. Where you're not interested in records, you're interested in like the actual columns. It's 100 to 1,000 times faster than the likes of those. So just a bit of you can't even see the KDB times it took in comparison to the others. So just a bit about the stats. So then obviously the question is, but KDB Plus is proprietary. There's a cost involved, and then you have obviously all of the open source platforms. So one of the things we say about that is, if you want to run an open source platform, use something like Hadoop for the sorts of queries, you need to have someone that understands all of these things, which I'm sure a lot of you probably know these, I don't know them very well, but you need people that understand so many different technologies, the total cost of ownership. I mean, Hadoop Stack in 2008, there was 4 open source platforms, and now there's more than 22. So there's a lot of overhead in terms of actually being able to do that, whereas with KX, one technology, one programming language, it's all very simple, it's all contained, and you can really leverage it. So even though there is a cost in terms of actually buying a language, the rest of the stuff is very easy to deal with. Okay, so I'm going to grab a chair and go through a little bit of the white demo here. Does anybody have any questions at the minute?
What does KX actually cost? And how's it licensed?
It's licensed per core. I don't quote me on the figures, but I think it's somewhere in the region of $25,000 or something like that. They have different packages for people starting out, and obviously there is a free version though, so you can go online. And actually, I'm going to show you here how quick it is to download and install it, because there's a free 32-bit version. There's no limits on it other than the fact it's 32 bits, so you can only obviously have 4 gigabytes of RAM and stuff like that. But in terms of like what you can do, like there's no limitations on the actual store. So let's see over here. Hopefully this will go well. Live demos are always dangerous.
Based on our history, you've got a 50% chance of this going well.
Yeah.
Yeah, oh, that's good.
Is that mine?
Sure.
That's mine. Yeah.
Heel slim. Jaloers. Geen drafles. Geen contact hebben.
How am I doing for time, by the way? Am I way?
Yeah, you put it.
So what?
How am I doing for time, by the way? Have I got much time left?
It's actually my job to count.
Oh, okay.
And I have not been doing my
Okay, so in terms, I'm probably not going to show you how to download because it is.
Okay, officially, there's 8 minutes left.
Okay, so I'm not
I,
bothering to
for
download.
one, am having fun, so if you want to go
Okay,
with that,
so
that's cool.
to download, you go to kx.com.
That's why it's so expensive, Dave, to let it remain.
Sorry? Yeah, so to download, select your operating system, enter your email address, download it. You install it, literally, it comes in a zip file. You open up your zip file and it looks something like this. So there's actual loads of other stuff in here because we've been messing around with this.
Window.
Basically, you have this file, it has a queue inside it, which is the queue exe file, which you run. You get this. Obviously, you can start this up by putting in path variables and stuff, so you can literally just go into your command prompt, hit Q, and you're away, and this is it running. So at the top, you can see it tells you what version you're running. So this is actually 3.1. I should probably get the newest version, 3.3, because it'll be a bit faster. My laptop has 4 cores, so 4 gigabytes of RAM. So, well, sorry, my laptop has 8 gigabytes of RAM, but obviously it's a 32-bit version, so I can only access 4 gigabytes. There's some other bits and pieces in there, but so at this point, like we have a general sort of just environment where you can do different functionalities. So one of the things is you have the idea of lists. So some inbuilt functionality to be able to sum lists. So this is the idea of vector processing here. Instead of having to try and sum up something by going through each element and looping through them, it just takes the whole thing and applies it to it. You can then also do the things like if you want to add 2 to each of those things, plus allows you to take advantage of that, so it just applies the 2 to all of the things in the list at one time rather than trying to loop through each of them. So you've got quite a few things that you can do there. So I've got a few examples here. So there's this quite standard sort of database. I'm just going to comment this bottom bit out. So comments, you just put in / and comments it out. Save that. Just don't want to get this table into memory. So this is just creating some basic tables. It's quite simple just to set up some basic table notation. And I'll talk about it in a second. So to load the file in, as long as we're in the right directory. \l, file name, loads in the file, and I now have my tables defined SP, and what was it, SP? So this is a fairly standard sort of regular SQL type example that people would use. Typical KDB or KX tables might not look like this. You probably, it has the full ability. The interesting thing here, SP is actually has a foreign key linkage to the other 2 tables. So I can do this. Oh no, that's not what I wanted to do. So if I want to just get the distinct P, I'll bring that a second. I'm sure what the problems are. So that gives me the ID and the city from the table, so I can just query the one table with the foreign key references to be able to get that in it. Because if we look at this, so meta allows you to see the underlying table structure. So the column name, the type of the column, so I've got symbols. So there's two different types of ways you can have text. You have strings, which are standard, a list of characters, or you have symbols, which are actually enumerated. So you have a symbol, and it enumerates basically in the background as a number, so it references a sim file. I've got foreign keys here then, so I have the S column has a foreign key to the S table. These are really bad names. P is the foreign key linkage to the P table, so you can do these sorts of quite cool queries. This is quite a good one here as an example. So in KB Plus to write a query that allows you to get all the details you want, SP and quantity, where you're looking at the cities are in the two tables. You have this many, half a line of code, and this is the equivalent what you'd have to be doing in SQL if you had the same thing. So because of the fact the linkages are actually pointing to the other table, it means that you can reference it in sort of in place in the query without having to do sort of the joins across the tables to be able to find what things are. You can update in place as well. So if I wanted to say, so I've got S, I've got cities, so I can do something like update country is equal to sort of London, Paris, and Athens. So we do
City.
Yeah, I'm gonna just do this. Be England, France, Greece.
Oops.
Tab. Well done. Oh, sorry, I've got listen. I'll do this. And pass it in my city. And so I can then, this dictionary can be stored somewhere, so you have basically reference that passes as things between. So just as an example of being able to do that, that doesn't persist it, so that is literally just querying the table. Persist it is easy, you just put backtick in there, basically changes the way that the tables are found in memory. So it's such an easy way, such an easy language just to be able to get into and start doing things with, because it is based around like the whole SQL side of it. It's a little bit different because if I want to just do a straightforward select, I don't have to do select star from S, I just do select from S, and it gives me the whole table back. Because these tables are in memory, so they're all they're ready to go. What I'm going to do now though, is I'm going to close that one and start again, because what I have is an on-disk database saved here, an example trade and put database. So I've got January and a few days in February there. So what's really interesting about the way the technology works is instead of storing everything in one file, it uses the underlying operating system's file system to allow you to basically leverage the way that the system's set up. So you can take your database, especially the fact typically with time series data you're doing things on a daily basis, it might be months. You can separate the data out, so each of the days are stored separately. Within that, you have your different tables, within that you have your different columns. The .d file at the top basically just tells it what types the columns are and what orders they're in, what should be there. And so everything is sort of stored separately, and each of these are then binary arrays effectively for KDB to be able to read, which is how, whenever it's reading them off disk, it's able to really quickly access them and use the advantage of the vector processing to be able to query them. So that's just sort of a sort of structure of how the actual database is designed. With this, it means that if you've got a system and you've got 5 hard drives, you can segment this between the 5 drives. So what will quite often happen is you might round robin the different days on each of the drives. So whenever you're querying, because people are generally going to be querying sort of bulk sections of days, if you're querying the last week, instead of trying to hit one disk to do everything, if it's round robin between 5 different disks, you're not going to. You can leverage the power of having all those different disks there available to be able to get access to. Because of the fact it's all in the underlying file system, you have a lot of control over how you do that. And all you just need is one file that basically just tells it where to go. I'm not going to go into that, but it's very, very easy to set that up.
So sorry, is it not just Windows centric then? It can be
Unix, yes. So like I'm only using Windows here because of the fact it's a Windows PC.
okay.
But typically, in more understanding, we're using Red Hat Linux. And everything. Yeah. So let me start this up. So loading the database. So loading in scripts with \l. It's the same with databases. It's all very straightforward. So sort of db / database. Okay, so that's it now loaded in. So these are my tables. So what just to note here is that these files at the bottom, sim is the list of all of the symbols that are used. Remember before I was saying that there's 2 different types of text, strings and symbols? Sim allows you to basically store on disk all the different symbols that you've got, and then all the actual symbols within all the tables after that are actually just enumerated, so you just have the index value of that sim file, which means reduces storage overhead and also allows you to query it a lot quicker. These here are actually binary flat files stored down on disk, so whenever you load them in, these are actually stored in memory. The rest of it is all memory mapped, so it's not actually loaded into memory, it's just memory mapped so that the process knows it's there. So what I'm going to do is just grab this and start doing some queries. So select from trade or sim equals IBM. So this is not a good way to form a query because of the fact everything's stored by date. You want to leverage that to be able to sort of go in and get the dates by themselves. By doing this, I'm trying to query the whole disk. This database is about 2.6 gigs, so that's a slow query because of the fact it's badly formed. It's one of the things whenever you're learning KDB+, you've got to learn how to query things properly because of what you want to take advantage of the way it's set up. So if I run this so \t allows you to time it, so we can see how long this takes. This will be a bit quicker because once you've run it already, it then is stored in system cache, so it'll be able to run a bit quicker than next time. So that took 100 milliseconds to run that once it was actually the table has sort of been brought into system cache. But if I put it with a date parameter in there, it doesn't even take any time as far as that's concerned. And that's because of the fact that that's measured in milliseconds, so it's actually a little bit too quick. So what I can do is I can run it 100 times, so you can see how long it takes to run it. So we run it 100 times. So 305. That's interesting. Yes, it took 289 seconds, so milliseconds. So I would expect that to have actually come off something. But anyway, must be some overhead there. But yeah, so you get the idea. Running it 100 times, I should do that. You can then do things like this. This will take a bit of time because I'm trying to query the whole database. So WAVage is weighted average. This is a size weighted average price. So it's something like a volume. So VWAP would be quite a typical thing that you'd use in banking, which is volume weighted average price. This is going to run across the whole table, so it's going to take quite a bit of time. Once again, by sim, that's all there. So that's 2.6 gigabytes. In fact, actually, just to see how much is in there, count trade, what have I got? 7 million rows. So that's how long it takes to query across the 7 million rows.
8 million.
Yeah, 8 million, sorry. Crashed it. Stupid Windows. Does anybody else have to use the command prompt in Windows ever? Pain in the arse.
I used to.
So we can do this instead. Select from trade where the date is the last date on disk, and sim is IBM. Very, very quick to return that. That's really fast when we do that. But that's because of the fact, it's able to say last date. It knows exactly where it's going. It's able to do that. And then just one thing I wanted to show before I finish the demo, just because this is what really makes it really cool. If I have something like this, select time price from trade where date is last price. This is the by temporal queries I was talking about earlier, where you have your trade table, and you want for each trade you want to know what the average or what the prevailing quotes were at that time. So this query here. So basically going to select the time price from the trade table, select the time, the bid price and the ask price from the quote table for the last day for IBM. And I can do this and I get my as of join, which is AJ. I'm going to paste this in. There we go, straight away. I mean, there's no, it doesn't take any time at all to run that. Just to see. 50 milliseconds to be able to do by temporal join from data on disk. So that's that's the power. I mean, other languages just don't have that sort of functionality built in. It's built into KX, so you can just run it really quickly. Does anybody have any questions before I finish the demo?
So that's literally from data on disk.
Yeah.
Well,
It's not because it's not because you've been querying the IBM thing.
Well, I can do is I can quit the process and try again. So quit process //. So we'll put the data in fresh. And I can change the sim also to have in the sim file again.
Will be as fast because your operating system cheats a lot here.
Sorry?
Your operating system kept all the data.
Yeah, it will have done. Yeah, okay, that's fair enough.
At the same times.
Restart the machine. No.
Normally I would say type this in your command line, but I have no clue how to do this.
Yeah, I'm not sure how to do Windows either, that's the problem. I can change the symbol though, see if that helps, but I think once again, because of the fact that I have been running it already.
So the benchmarks you had before was 16 cores for 256 gigs of RAM, so it's basically one core equals 16 gigs of RAM. Is that the recommended sort of trade-off?
Well, so you've got a few different ways you can do it. With something like this, if you've got 16 cores, what you'd probably actually do is have one process and then have slave threads. So to basically be able to multi-thread on disk, what I can do, let me put out this process. I've got 4 cores, so what I'll do is I'll do Q minus S, 2, and now I've actually got 2 slaves that I can run this on, so whenever I query the things, if I want to query different dates, what I can do is if I use to build multi-thread, if I was to do something like 1 plus X each. So I can do that, to multi-thread that, I'll do that, and that's multi-threaded then across the cores. So when you're querying on disk, you can take advantage of that. So if you've got 16 cores, what you probably do is set the process up with 16 threads or slaves to be able to query the disk underneath, and just have the one process that has access to the full 256 gigabytes. Yeah. So anyway, that's a quick demo. I can change the symbol, but I'm not sure what else I've got in there. I might have MSFT, but.
So is there a massive demand in the sort of investment banking industry for tech series specializations? What's the...
like someone that is like a good KX developer is worth a lot to these banks, and hopefully in other, which is great for me, and hopefully in other industries soon, as I'm about to go into, because I've got the rest of my presentation here. I think the next, where am I? Here.
I was working with Java developers at Barclays who were specializing in teaching me how to work with KX. But that was the language stuff, they did not actually know it, but we were forced to work with it.
Well, that's the problem. If you don't know the language, it looks very off-putting because of the fact that it can't, the way it's traditionally written by people that, if you go back 10 years when they were implementing a lot of these things in banks, people liked the fact that no one UK, plus they kept everything as terse as possible, because they could write it really terse, because you can write, you can squeeze things down to being half a line of code and not make any sense to anybody, but it means it's very sort of prestigious, and unless you're a KX developer, you can't. That's complete rubbish, and we're trying to change that by saying, well, actually, anybody can learn this. It's really easy to learn really quick, especially if you've done SQL and the likes before. But looking at some old code, wherever it has been written in the ISDIP, you're just like, what are these guys doing? And they don't put comments in their code either. There's just lots of bad practices that went on in the past that we're hoping will change it, and as we move into other places. So we're going to just quickly talk. I think I'm probably running out of time here, aren't I?
You are.
Yeah. So just quickly, looking outside of finance, sensor analytics, because of the fact that at the end of the day, sensors are all time series. It's going to go into architecture, but I don't really have time. Some of the different things that we're getting places from, so you can see that, this is actually a dashboard that we have, but it allows you to do like heat maps and stuff, so it all integrates with charts. You can store geolocations and everything like that to be able to search through them. It's all searchable. I'm just going to skip through all this satellite data. So one of the things is looking at the sort of Hipparcos satellites and stuff like that, and you can then go on your data plots, and obviously that's huge amounts of data as well. I don't have time to go through everything. In terms of resources, KX wiki page, KX community, blah 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 blah. This is the section of the agenda, which was a little bit more marketing. This is the page I wanted to get to. Free 32-bit download. Give it a try. It's good fun. Select your operating system, enter your email address, agree. Be careful not to crash your machine. If you use up too much memory, you can only use 4 gigabytes, so hopefully you have a machine that can handle that. Yeah, 64-bit version, if you want that, you need to speak to someone in KX. If you are interested, I'll have my cards here, grab a card. There's some pieces of paper here that have some more information about stuff. You can have a read through those as well if you want. I'm afraid you can't take those away, but if you want them, let me know and I can get some stuff sent out to you. Community meetup, so we're growing, we're getting there. So now, New York, London, Hong Kong are traditionally our biggest meetup locations. Sorry, and Singapore's in there somewhere as well. But we're moving around the world, we're getting there, and hopefully everybody will soon have at least heard of us, because I think what has been the case up until now, there's probably more people that actually program in Java than there are people that have heard of KX. So we're getting there, and hopefully it's been interesting anyway. If you have any more questions, I'm happy to talk to you. Remember, have a learning book, so if you want to learn it, This is a good textbook to have. Put your name down on the sheet that I've got. I'll ask them not to bombard you too much with emails, but that's not my job. I've just been told to take the names so that I can use it for the raffle for the book. So yeah, it's a good book to have. It's the newest version of the book, running in 3.0. Things I didn't get to talk about is the fact that KV Plus, interfaces with other languages, JSON, and other bits and pieces. But maybe next time, if I get invited back, I can go into more detail on some of the technical things and actually show you some good examples. Because at the end of the day, this has just been an introduction to the language, because I'm sure that not many people have heard of it before. But yeah, any questions? Oh, sorry, appendix for things. Any questions?
You showed a graph with like the benchmarks between like all kinds of different data solutions. Do you happen to know how much pre-processing went into every data store, and specifically KX, to go down from 100 terabyte to 1 gigabyte?
I don't. I think there was. They did have something somewhere that they basically told them how long it took them to install the language on the machine, get the data, and store it down. I don't have the stats on me. I'm sure it'll be very favourable to KX because of the fact they know how to do it. But it's very simple because of the fact you can, if it was in CSV, for example, there's a built-in CSV parser. I can show you. I don't have a CSV to use, but like to bring something from CSV. If I just give you an example, it's not going to run anything because I don't have a CSV file. But you would literally just do something like the type of columns. So say I've got a sim column, I've got a time column, I've got a date column, I've got a float. List.
Is there also a U-type? Because then you can type STFU, and it's like all the fun.
Sorry?
Is there a U-type? Because I see like the
U
types.
What different types do we have? There is a U type.
Nice. Next time type STFU.
Yeah, like so I've got. There's all sorts of types. Oh. I'm not sure exactly what you're meaning there.
STFU is like shut the fuck up.
I think use like minutes or something like that, so I can put that in if you want to. But yeah, the other thing, it had nanosecond precision as well. So like the dates and times are all built-in formats, which is really powerful compared to a lot of other database technologies that don't actually store dates properly. They're used as floats and sort of underlying. So querying by date and time is really easy to do because it's good. So being able to put in a CSV is pretty much that. You wouldn't want to do it all at once. What you'd probably do with the 100 terabyte data is you'd chunk it. So you'd chunk it by by something like that. But there's stuff ready to go. Like go to code.kx, which is the wiki page. And there's code there ready to go for it. What it does is it'll load it in the chunk, save it down to disk, load it in the next chunk, save it onto disk. It'll take however long. Basically, it'll take however long it takes your hard drive to store it on your disk, because the processing KV Plus will take no time at all. Yeah. Okay, I'll get off stage so you can move on to the next talks.